So, for the initial ideas, the conceptualization process was divided into two parts: concepts for the development of a moisture sensor and the full implementation of the sensor for the overall bedwetting alarm system. Both sensor concepts are based on the same circuit schematic, consisting of two electrodes, one of which is connected to the Arduino Uno's 5-volt power and the other connected to an analog input, as well as a resistor connected to ground. In the absence of moisture, the circuit remains open and the input voltages are zero. In the presence of moisture, the circuit is effectively closed as a current can flow through the urine, which is conductive, so an increase in voltage readings is detected. In sensor concept 1, the circuit is implemented into a foam pad with conductive thread electrodes stitched into an alternating pattern, whilst concept 2 utilizes thin copper foil electrodes. Both were compared using an unweighted decision matrix based on factors such as relative ease of maintenance, sustainability, user comfort, and overall cost, and Sensor 2 was eventually selected for further development in the final design prototype. Moving on to the first product design concept, which comprises of a foam sensor pad, which is designed to be placed on a user's bed, and wireless communication between the systems processing unit and alarm is utilized. Product concept 2 involves the attachment of the electrodes to a user's incontinence pad and employs a wearable transmitter module, which uses a wired signal to an alarm system that can alert a caretaker of the incident. Finally, product concept 3 consists of electrodes embedded into an incontinence pad again, and in this design, a processing unit and an auditory alarm system can be mounted nearby and alerts both the caretaker and user of an incontinence incident. Again, these designs were compared using a weighted decision matrix, and considerations were given to criteria such as functionality, ease of use, response speed, and cost. Concept 3 obtained the highest overall score and was used as the basis of the final design.
The final design consists of two electrodes positioned lengthways within the material kept close together due to test results concluding that this decreases the alarm's response time. In terms of the circuit, one electrode has power and the other is connected to ground through a resistor, the latter also being connected to an analog input to the Arduino, recording voltage, which reads 0 when dry. When the space between the electrodes becomes wet, the dissolved ions in the urine allow a current to flow between the electrodes and therefore voltage is detected and the alarm sounds. Here is a final concept for the casing, housing the Arduino, battery and speaker.
This design splits the case and cap into two parts, and adds a finger handle on the cap for caregivers opening and closing the box by plugging in or out. The top is designed with a bottom port, an audio hole, and two cable routing holes. About the inside, the first layer will house the Volcano and speaker, and has a hole to the lower layer that can hold the battery.
Yes. You take a video?
Yes, I'm taking it.
Is this actually buzzer?
Yes. To start the alarm.
Switch it off, it works.
Okay.
In terms of cost, based on the prices of each component used to build the sensor, it would come to about £33, which compared to some of the market prices is a very competitive price. One sensor can be reused over and over, which is not only good for the cost, but also for sustainability. Once the probes are dry, the sensor resets to its original state, and the probes can easily be inserted into a different diaper. So to reuse the sensor after an accident, the caretaker responsible would simply have to clean and dry the probes and reinsert them into a new or different diaper. To be more environmentally conscious, a reusable washable diaper, like this one from Amazon for example, can be used as they are very commonly available.
I know gold is not enough.